Hello and welcome to the tutorial in the series of Oneat tutorials. In this tutorial, I'm going to show you how to use the CSV file of detections of mitosis events that comes out of Oneats that we cleaned yesterday using the Oneat visualization wizard in TrackMate to actually correct the lineage trees. Now, TrackMate is the most popular tracking solution which is available in 3G/Java, and by default TrackMate gives you frame-to-frame linking and segment-to-segment linking, so you can actually get the dividing scale cells from TrackMate algorithms using default cost metrics of distances, and also customized cost metrics of using the size and intensity information of your cells in the process of tracking. Now that gives you a lineage tree which you then have to correct, and now the purpose of TrackMate Oneat as an extension is to actually leverage the information that Oneat has there, where it knows the location of dividing cells, and then it can check if TrackMate lineage trees actually comply with what Oneat is detecting, and if not, it's going to do the corrections. And in this particular tutorial, I'm going to show you how TrackMate Oneat actually does that kind of correction for the lineage trees. So the first thing you have to do is you have to have a data set which contains integer label image with your data. So one channel is the integer label image and the second channel is your raw image. And right now we need this for actually doing the TrackMate Oneat. So if you don't have this, please consider creating your input data in this form, where the first channel contains, or the second channel contains, the segmentation, and the other channel would contain then the raw image. So I'm going to just see only one channel, which is the raw image, and then I'm going to start the process of tracking using TrackMate, which is, and then you will see in the TrackMate panel you have your calibration settings which are set up. You use the label image detector and give it the channel of your label image, which is channel number 1. It starts the detection process, and then it will show the detected cells in this purple color. And now we are going to use the LAP tracker for doing the frame-to-frame linking and segment-to-segment linking using the distance matrix and a customized cost matrix function. And here it's the distance that I set up, and here are the few penalties, and then I also have the gap closing and track segment splitting where it takes care of the dividing cells. So I'm just going to do this process of tracking. I'm going to show you the track scheme, which we will keep on the side, and then I'm going to use the TrackMate Oneat extension to correct the tracks, and then we will compare the two track schemes and see how TrackMate Oneat is in correcting these tracks, if it needs correction at all. So we don't want to see the entire tracks, we see only the selection, and then I'm going to start the track scheme, and then I'm going to move this to another window, and I will keep it there to compare it with the TrackMate Oneat track scheme later once I have started this extension, which is actually in this last panel over here. So you go here, you see the launch only track corrector, and then you have to press execute to launch it. Oh boy. And here's our panel for doing the correction. So you can load the detection file of mitosis, which is this clean one that we had yesterday. And you don't have any apoptosis file, and then what you can do is meter the events if you have to, but this probably is a step that you already took care of in Python. And then the allowed time gap between Oneat and TrackMate events is like if TrackMate found a division and Oneat also found a division, but there was like a plus minus 2 time frame difference between the two, we are going to say, okay, we don't need to correct this particular track because it was correctly identified as a mitotic track. And if this doesn't happen, then Oneat actually takes that track ID, puts it into correction to actually find or link this track with the other segments. And then you have these two options of correcting the tracks. Either you create new mitosis events, which are the events which have been verified and they exist in this Oneat file, but TrackMate missed them. Or the other option is to break the mitosis events. That is, if TrackMate says it's a division, but Oneat says it's not a division in this plus minus 4 time frames, so you are going to break that link and not have that as a division. And then you press OK, and it will start the process of this correction, where the steps are: first get all the track IDs, then verify if these track IDs which have mitosis events conforms with Oneat locations. If they don't, then you have to do breaking of the links first and then creating of the new links later. And after this process is over, you can go back and you can visualize the track scheme which comes out of correction. And the goal of this tutorial is to compare that track scheme with the track scheme which came by default from TrackMate, which we had in the previous step. So let's just wait for this process to be over and see what happens. So here it's actually still using the segment linker algorithm of linking the segments that Oneat has found, but locally and not globally. So it's solving a local cost matrix where it has a segment which has been identified as the mother cell track, and then it is having the segments in the next frame, but in a small location of a small region which you chose for the track linking part. So it only sees those track segments and can only link with them. So it's kind of like solving it locally, the segment to segment linking problem, than solving a global optimization problem, because it makes sense here because we know the information about mitotic cell location, so we have to leverage that information by kind of forcing the solver to find the proper links based on minimizing this cost matrix locally. Okay, so once the process is over, it says that it has total tracks which were this much in the beginning, and now the new tracks are this much. So go back and let's launch the new track scheme. And I'm going to put the track scheme, the new one, over here. I'm going to bring the old track scheme coming from the default TrackMate algorithm and put it here. And you need like two screens to actually do this more thoroughly, but since I'm making a video, I can only do it with one screen, so I'm just going to make it a bit vertical instead of horizontal. And then we can see, okay, let's go and see where TrackMate thought there was a division. And here Oneat actually broke this link because it wasn't in the detection file. So let's see if it was correct to break this link. Seems like it because I don't see any division here, whereas TrackMate found this as a dividing cell, right? So this was broken by Oneat because this is not a division. So this was a correct decision made by Oneat, right? Let's see more divisions in the original tracking. Here I found another one where TrackMate recognizes as a dividing cell and Oneat said no. So let's just follow this cell and see what was happening here. I think I know why TrackMate made a mistake here, because this cell actually doesn't divide. It is the cell next to it that divides, right? So that kind of confuses TrackMate, kind of confuses the segment linking algorithm of what is actually a dividing cell, because as you can see that it links it thinks that this cell actually split, whereas it was this cell that actually split. So it's, in this way Oneat is actually nice because it prevents these mistakes automatically. So it's confusing for automated tracking algorithms of TrackMesh to identify the correct division when it is actually next to a correct division. But for Oneat, it knows the location of these dividing cells because it has the segmentation information. So it made the right decision to actually break this particular link. Now let's go and find some more. And this is another example. I hope you can see this. I know you cannot see my mouse, but this is actually this cell. So I'm following, right, this one. And here, this is the default TrackMate scheme. TrackMate said that this cell is actually mitotic. Oneat said no. And now let's follow this cell to see. So the cell is in pink. So if you just zoom into your screen, you will see this. So I don't know why TrackMate found this as a division, because here clearly this is not a dividing cell, and I do not see any cell next to it also undergoing division. So yeah, so this was actually nice that this link was actually broken, right? And another example here where TrackMate found mitotic cell, but only didn't consider this as a mitosis, so it was also broken. Now let me actually go and see in Oneat what it found as a dividing trajectory, which would also probably be present in TrackMate then. So here, for example, I went into the Oneat track scheme, and now in this particular track scheme, they both are actually agreeing, and now I have to find where is this. Ah, this is this one. It's in pink or purple. I don't know the difference between the two colors. So it's this. And Oni said this was a dividing cell. TrackMate agreed, and let's see what happens now if they are both correct, because I don't think they both can be wrong. So this indeed is a dividing cell. Okay, so this one, and yeah, that's were the two fragments. So Unit was able to say, okay, this is division. TrackMate, do not break it. I won't break the TrackMate links. So this is the right decision again by Unit. So in overall, my message here is that the track scheme that you get out of Oneat, even after you have an erroneous linking of tracks in TrackMate, can be corrected by Oneat. And the overall goal of this whole project is to improve the accuracy by putting all these powerful algorithms together in combining Python and Fiji worlds to get optimal tracks out of this thousands of tracks which you will get. And this is just an example of a small data set. You will have much bigger data sets than this, and I want Onis to be able to correct those lineage trees. And for this you need one, a proper Oni trained models, and for this you need training data. So if you have any questions or problems in creating that training data, ask me, and I will be happy to create this kind of trained models for your data set, so you can also get these nice lineage trees in the end. So please try this out, and I will ask my colleagues if it's okay to release this as an example data set. Otherwise, contact me and I will make a training the data set for you, so that you can actually verify this kind of lineage trees between TrackMate and only corrected TrackMate. Yeah, that's all for today, and well, have a nice evening.